Hello everyone and welcome back to Kanai's A Lab. In this video, you will learn how to predict customer retention or customer exit. That is, a customer stop using a particular service using machine learning techniques. We will guide you coding by coding steps of building a predictive model to predict when a customer is likely to leave based on the data. Before moving to the coding, let us understand the customer churn concept. What is customer churn? A customer churn is when a customer stops using a service or a product. Predicting churn is crucial because it helps business to identify the risky customers and take proactive steps to retain them and protect the revenue of the organization. By predicting who might leave, business can improve customer satisfaction and reduces the losses and make smarter decisions to boost the growth. The dataset include customer ID, balance, age, tenure, which are the features to determine customer behavior and likelihood to leave. The columns like geography and gender, which are the categorical features that may influence customers' decision. The column exited, which are the targeted variable for us, which is nothing but indicating whether a customer stop using the service, which is having 1 which belongs to left and 0 belongs to the state consumer. A machine learning approach always starts with the process of data processing. Then it goes on different steps of data processing like missing values, encoding the categorical into numerical variable, like in this case, geography and gender, etc. And sometimes scaling the numerical features to ensure consistency across the data set. Next, we'll move on to model training, which is nothing but building the machine learning model to predict the customer's likelihood to leave. And finally, we will evaluate the model. The evaluation consists of finding the accuracy or confusion matrix or any parameters to understand the performance of the model, including the classification report. Let us start coding using Python now. For coding, we will be using Jupyter Notebook. So we will be starting the steps in coding by importing the library. We have pandas for data manipulation, NumPy for numerical computing. We have label encoder which encodes the categorical values into numerical values. We have splitting a data set into train and test. Train is for machine learning training and test is for model prediction, which is from again scikit-learn. We have standard scaler for scaling the numerical variable, making it to common scale. And also we will be having a machine learning algorithm from the scikit-learn, which is logistic regression. And if you have enough time, you can try the another machine learning algorithm, that is support vector classification, again from scikit-learn. So we will be having the confusion matrix, classification report, accuracy score, all the model evaluation from the scikit-learn. So we are going to import the first steps of importing libraries. The libraries imports are completed. Now we will be loading the dataset, which is in the form of a CSV file. The name is churn.csv, and this is going to read using pandas read underscore CSV function, and we are going to loading the first 4 rows of the data. Let us see the first 4 rows of the data. We have all the numerical columns, all the columns are there. Now using a function of info, we will be having the enough information of the data, how many variables, how many rows present in the data frame. This is a data frame consists of 1,65,000 rows and which is having 14 columns. Some of the columns are integers, some of the columns are float variables, some of the columns are object variables. And if you want to find the statistical summary of the data, you can use the function called describe, which used to give the function like what is the mean value, what is the standard deviation, minimum, quartile, first, second, third, and what is the maximum value, which understand or which get the insight of the data. So after that, we will be having another pre-processing stuff, which is nothing but scaling the data, categorical scaling into numerical values, which is something called encoding of the data. The encoding of the data, we need to identify which are the columns comes under categorical object, the data types selecting, which is only the objects from the columns and displaying. We can see that surname, geography, gender, which are comes under data type of object. And we are going to numerically converting, we are going to categorical columns into numerical conversion by using the function label encoder, which is from the scikit-learn. We will be taking a function called fit underscore transform. We will be selecting the column. The columns are nothing but surname, geography, and gender. These columns are fit underscore transform, identify and transforming into numerical entries and displaying the numbers after transforming into numerical. You can see here. So this everything is conformed into numerical scale. Now the next step, that is very important step, which is defining the features and target variable. The target variables are the dependent variables which depends upon the features x1, x2, etc. So the x are nothing but the columns, everything excluding the column exited, right? Which is a column from the data frame. So we have x, which is nothing but all the column dropping exited, and we have y, which is nothing but the data frame having only one column exited. Let us print the data frame shape, how many rows and how many columns. So the X data frame, we have around 1,65,034 having 13 columns, and the Y data frame having only one column with 1,65,034 rows in number. Now, after splitting into X and Y, we need training data and testing data. The training data is only for machine learning training, and the test data, which is the secondary data, which is going to utilize after the model building. The model is going to test on the test data to get the predicted variables. So using the function test train underscore test underscore split from the scikit-learn, and we will be having x train, x test, y train, and y test, which will be dividing 80% of data into train and 20% of data into test. And we will be using a function 42 because I need every iteration, I need the same answer. I'm keeping the value storing into a particular memory, the data retained same. And I want the proportions of y, which is nothing but what is the final value, which has to be proportionally same in the divided also. That's why stratify y is equal to y argument is using especially, which is good for some data which is imbalanced sometime. I want to understand what is the training shape, which is having around 1,32 and 13 columns, and this have 1,32 and this is having only one column, that is y. The test data shape only 33,000, which is splitted on the base of 80-20% fraction. So moving to the machine learning model building, I need to import the algorithm logistic regression, which is from scikit-learn. I'm going to instantiate the model logistic regression, and I'm going to train the model using the fit function. For the fit function, I need to pass the arguments of training data, which is nothing but x train and y train. So I'm going to pass the training data to the logistic regression algorithm using the fit function. Let me see whether the training is happened or not. Yeah, the train happened successfully, which is nothing but identify the parameters. Once the model trained successfully, we are going to utilize the model. The model name is logistic underscore model, which is going to use for the prediction. The prediction, we are going to pass the new data, which is nothing but x underscore test. I need to understand what is my predicted value. You can see here, the predictions are 0, 0, 0. There are so many numbers. Based upon that, either 0 or 1, which is the probabilistical value, based upon the cutoff. The cutoff by default is 0.5. If anything comes under 0.5, which will go to 0, anything greater than 0.5, which goes to 1. This is how the logistic regression works out. Next, we wanted to understand what is the performance of the model. We will be having a function called accuracy score, and also we will be having a function called confusion matrix. Both are equally good to understand the performance of the model. So it's not only accuracy and confusion matrix. Sometimes we will be using different parameters for identifying the performance of the model. In this case, we are going to take accuracy score and confusion matrix. Let us see what is the performance of the model. By seeing the matrix, you can see here the accuracy comes under 78%, and the confusion matrix you can see here 26,023 and 0, which is nothing but the good classification, classified positively or classified correctly, and the other diagonal 6,984 numbers are predicted wrongly. That's why sometimes some models will behave not good. So sometimes we need to go for the secondary model like support vector classification or any other classification model. So within this particular demonstration, we identify the simple steps of doing a machine learning approach, starting from loading, pre-processing, splitting the data, model training, model evaluation, finding the evaluation parameters. So you can extend the algorithm to different and check whether any performance improvement in terms of misclassification. So with that, we are going to conclude this video on identifying the customer churn using the churn.csv file. Hope you understand machine learning approach. Hope you understand the process of machine learning. Stay tuned for more informative content on machine learning. Thank you once again for watching this video.